Assalamualaikum and a very good evening. This is my team and we will do a demonstrations about our mini project in the subject of computer aided project management. So this team is consists of me. My name is Shahazureen Ikwan bin Abdul Rahman and this is my team partner.
My name is Mohd, Afifi, Syafiq and Omar.
And we will start our presentation about the mini projects. Now before we start our main project here, we will start briefing about the the problem descriptions. So the problem description is from the company,
which is named by New PCB Manufacturing Sdn Bhd,
and it has a problem on and experiencing a severe backlog in sales order due to antiquated machinery and poor planning. So now, as we can see here, this is the problem descriptions. So this is the project description in here. So we start this company start with a PCB layout. So it's printing a PCB and okay, now we are going about a detail about the plan layout from this company given to us. So they will consist of lot of product in here, but I will tell you the name of the buffer and the machines. So the machine here start with the S-Print 1, S-Print 1B, the C++. So it consists of 3 levels. The first level will be in the S-Print, so it's printing the PCB, the pattern of the PCB. And the second one with the placement, so it will place the component on the printed PCB, and there will be a shape. So this one is shape. It will shape the PCB layout, and then it will flip. So, but because of this 3 level, it can go directly by shipping. But there is another level, the decision level, which it can be flipped by the other side. So it will be another printing on the other sides, same as the previous actions. So as you can see here, this PCB consists of 2 products, which is part A and part B. So these 2 products will give a different pattern of assembling the product. So for part A, there will be 2 decisions, same just like as part B. So for part A, they will consist of 40% for one side of printed PCB. But for the other 60%, there will be double-sided printed PCB layout. Same as for part B. But for part B, it consists of 30% for one-sided and 70% for two-sided. So that's the plan layout of the company given to us. Okay, as we can see here in the production information, so there are 2 parts as I was mentioned previously. For the part A, there will be 300 panels for every 240 minutes. As for part B, there will be 50 panels for every 240 minutes. So for the number of PCB per panel, for part A it will be 3 PCBs per panel, and for the part B will be 4 PCBs per panel. So there is a number of combinations for product PCB, for it can be read as mentioned through this table. So after the explanation about the table, so we're going through the solder printing machines. For the 4 machines, S-Print 1, S-Print 1B, S-Print 2 and S-Print 2B. This was mentioned, as I mentioned before, the S-Print for the one-sided and the double-sided. So and here, after this, we know about the solder printing machine already. So now we are going to the buffer capacity. So there will be 2 types of buffer. So this one for line 1 is for the part A, and the line 2 for the part B. And in one line there will be a 2, which has 2 conditions for the one-sided and the double-sided. So for part A, for the buffer B line 1, it will consist of 1000 panels, and for the B lines 1B, which is double-sided, will be consist of 100 panels. And for the B line for part B, the same as for the part A, is for the B line 2 will be giving of like 1000 panels, and for the B line 2B will be given 100 panels. So now we are going to the machine cycle times. So this machine cycle times is just focusing on the printing machines. So for the printing machine, all of them are given by 0.7 minutes per panel. Now we are going for the setup. We're going to focus on setup for the printing first. So the printing machines consists of one on this setup, which is the indexing operations, which given a setup time of 0.1 minutes. And there will be a machine's breakdown for the printing machines. This focus for printing machines only. So for breakdowns, there will be two operations, which consists of machine assist, and one will be the breakdown. So two of them mode as a busy time, and the mean time between failure for the machine assist is 20 minutes, and the mean repair time will be 1 minute. For the breakdown, its mode is busy times, and the mean times between failure will be 1800 minutes. Am I right? Okay. Yeah. And the mean repair time will be 45 minutes. So now we are going to the chip placement machines, the company machines here. So these chip placement machines, there will be calculations to take its cycle time. So the calculations are based on this table. Okay, so now we are going to the line buffer capacity. So this one is focusing on the chip placements and the shaping the PCB layout. So now we are focusing on line buffer capacity for each of the buffer. Each of the buffer is only required for 2 panels only. And for the machine placement time per components, there will be slightly difference. For C plus 11, C plus 12, C plus 16, C plus 17, C plus 21 and C plus 26 is just 0.19 seconds. For the O shape 11, O shape 16, O shape 21 and O shape 26 is given by 0.85 seconds. So this is the machine setup. This machine setup is focusing on the chip placement, on the PCB layout. So as we can see here, the setup is just the same as the previous one, just like the printing machine setup. So it just consists of indexings only. But for the failure, it has a slightly different from the printing machine segment. So as you can see here, there will be 3 types of failure. The first one will be the machine assist, breakdown, and checking. So this one is additional. The checking is an additional, like from the previous ones. So as for the machine assist, its mode is busy time, and the mean time between failure will be 30 minutes, and the mean repair time is 2 minutes. For the breakdown failure, the mode will be busy times. It's 1800 mean time between failure, and the mean repair time will be 30 minutes. And for the checking time, the mode is available time. The mean time between failure is 60 minutes, and the mean repair times is 1.5 minutes. Okay, now we are focusing on labor. This labor is responsible on doing a repairing for each of the failure happen between the machines. So as you can see here, in buffer B oven 1 and B oven 1B, B oven 2 and B oven 2B, it's travel for 20 minutes. So there will be a delayed time for these operations in the buffer. So the capacity buffer for this buffer is 30 panels. So there will be 30 panels and the delay time of 20 minutes. So now we are going to the machine flipping, which is the process on flipping the PCB layout for the one-sided to a double-sided for printing. So now the operation time for flip 1 and flip 2. So there will be 2 parts for part A and part B. So there will be 2 machines, flip 1 and flip 2. but the operation to make it the panel upside down is for 0.4 minutes. And the last of the operation will be the inspections of the PCB layout. So there will be two machines. The first one will be the inspect 1 and inspect 2 for part A and part B. The operation time takes only 0.5 minutes. Okay, now we are focusing on the objective of this mini project. The objective is to increase the total output, and the budget for these changes for the improvement is only not exceeded by 100,000 ringgit. So for the operation time in this project will be the total time for this project operating is 128 hours. So these are the costs for the improvement changes. Okay, now I have done my part on explaining the project descriptions. So now we are moving to my team partner, so he will explain you about detail in our mini projects.
Alright, thank you Shahazureen for the explanation. Okay, now I will explain on how to set the properties on the quest simulation. Okay, the first step is to create two sources, which is source A and source B. Source A is made for part A and source B is made for part B. Okay, then we have to set the properties of the source according to the task given. Okay, for source A, the first we have to set the lot size, which is 300 panels, and then we have to set the IAT, which is 240 minutes. Means that there will be 300 panels produced for every 240 minutes. Okay, that's for source A. Then for the source B, the same step are used, which is by setting the lot size and the IAT. For part B, the lot size is 50 panels, and for the IAT is 240 minutes. Alright, we proceed to the printing machine. For solder printing machine, there are 4 machines that have to be created, which is S-Print 1, S-Print 1B, S-Print 2 and S-Print 2B. S-Print 1 and S-Print 1B is for part A, and S-Print 2 and S-Print 2B is for part B. Okay, I would show on how to set the printing machine. For example, I would show on how to create S-Print 1. Firstly, we have to click on the machine, and then we create a new machine which named by S-Print 1. Then we have to create the cycle process of the S-Print 1. Okay, by clicking the new process, we can create a process which only for the S-Print 1. And after we have create the name process, which is process 1 for the S-Print 1, we will set the part. Okay, we will put number 1 in part A, which means that only part A can pass through S-Print 1. Okay, for part B, we will put 0, which means that part B will not passing through the S-Print 1, because S-Print 1 is made only for part A. Okay, then for cycle time, we have to set the cycle time of the machine, which is 0.7 minutes per panel. After we have done these 2 components, then we will click OK, and that's all for S-Print 1. The steps are repeated same for S-Print 1B, S-Print 2 and S-Print 2B, because the cycle time is same, which is 0.7 minutes. Next one is machine setup. Okay, for S-Print 1, S-Print 1B, S-Print 2 and S-Print 2B, the machine need a setup which name it by indexing. Okay, to set the indexing, we have to click on the machine. For example, sprint 1, then we have to click on the setup process. Okay, then we have to click on the new process and name the process by indexing. Then we have to set the parts of the indexing, which is part A, which means that only part A can pass through in the sprint 1. And then for cycle time, we have to set 0.1 minutes. Okay. The steps are also repeated for the other 3 machine, which is sprint 1B, sprint 2 and sprint 2B. But the difference is there are for part B, we have to set the other indexing as part B will only use
it's only focused for part B only.
Okay, thank you. Okay, indexing 2 will only focus on part B. So for indexing 2, we have to set the part required, which is part B only. Means that we have to put number 1 in part B only, so that only part B can pass through in the sprint 2 and sprint 2B. Okay, that's all. Next is for the machine breakdown. There are 2 types of failure in the machine breakdown, which is machine assist and breakdown. Okay, so how can we set the properties of the failure? First of all, we have to click on the ops in the model, then we click on the create modify failures. Okay, then we name our failure. For example, we name our failure with machine assist. Then we have to set the failure mode, which is busy time, and we have to set the repair process. Okay, we can name anything for the repair process, and for this project, I name my repair process is machine assist R. Okay, then we have to set the properties of the machine assist. Okay, for the mean repair time, we have to set the elang distribution, and the mean repair time is 1 and the K value is 3. Okay, and for the failure distribution, we have to set with exponential, and the value of the mean is 20 minutes and the starting stream is 1. And we will also repeat the steps for breakdown, but with different properties. Okay, we proceed to chip placement machine. There are several chip placement machine in this project, which is C place 11, C place 12, O shape 11, C place 16, C place 17, O shape 16, C place 21, O shape 21, C place 26 and O shape 26. Then we have to create the line buffer. The line buffer for every machine consists for only 2 panels, and then we have to set the machine placement time per component. The calculation of the machine placement time per component are shown in the table. For machine setup, the chip placement machine are using the same machine setup with the solder printing. So we just have to put the indexing in every chip placement machine with the same properties of indexing with solder printing machine. For the failure, there are 3 failure in the chip placement machine, which is machine assist, breakdown and checking. And for the machine assist, we have to create the machine assist for label 1 and label 2. And same goes also for checking. We have to create two checking, which is for label 1 for part A and label 2 for part B. And how to create the failure? We have to click on the create modify failure, and then we name the failure with machine assist 2 label 1, and then we set the failure mode with busy time, and we set the repair process, and then we set the failure distribution. Same goes to checking. We have to set the name, the repair process, and the failure distribution.
And don't forget about the breakdown too. It was the same set.
Same step also. Next, we go to the label. For the task given, we have to create two label, which is operator LC place and operator LC place 2. Operator LC place 1 is responsible for the setup of machine assist and checking of machine C place 11, C place 12, C place 16, C place 17, O shape 11 and O shape 16. While for LC place 2, it have to conduct on machine assist and checking task of machine C place 21, O shape 21, C place 26 and O shape 26. Okay, how to create the label? First of all, we have to click on MHS, and then we have to click on the label controller. Then we create two label controller, which is label controller 1 for operator LC place 1 and label controller 2 for LC place 2. Then we create the label element. Label A is for part A and label B is for part B. Next, we have to create 4 buffer, which is B oven 1, B oven 1B, B oven 2 and V oven 2B. And in the task given, it said that the parts travel for at least 20 minutes and each oven can only take a maximum of 30 panels. It means that we have to set the buffer capacity with 30 and the delay time with 20 minutes. Okay, first we have to create the buffer. We have to click on the buffer and then we create the B oven 1 buffer. Then we have to set the part capacity, which is 30, and then we have to set the delay time of part A, which is 20 minutes. Why we set the delay time on part A? Because B oven 1 is for part A. If for B oven 2, we have to create the delay time on part B because B oven 2 is for part B. Then we go to flip machine. For flip machine, there are two flip machine which is flip 1 and flip 2, and both machine required 0.4 minutes to flip. And lastly, for machine inspect, there are two machine inspect, which is machine inspect 1 and machine inspect 2, and both takes 0.5 minutes to check the panel. Alright.
So for additional informations, for the B oven 1 and B oven 2, this is the decision point whether the PCB will be one-sided layout or the two-sided layout. So it will be consist of part A will be 40% and 60%, and for the part B will be 30% 70%.
Alright. Before I forget, we have to set the proportions of the B oven. This is because we are separating for part A 40% and 60%. Okay. How to create the properties of the proportion? First of all, we have to click on the buffer oven 1 which we have created before. Then on the B oven 1, we have to click on the part routing, and then we click on the proportion and we set the output 1 for part A is 40 and output 2 is 60. Then we have to click on the logics and choose on root logic, and we click on the proportion to activate the proportion root logic. Then we have to click on the process logic and click on pass with delay logic. The steps are repeated for B oven 2, but with different properties which we set it for part B. And for part B, we will divide it into 30% and 70%. Okay. After all the machine and buffer are created with the correct properties, then we have to set the connection. The connection are important so that we can fix the root of the machine and the buffer. To set the flow of the process, we have to click on the model and click on build. Then we have to click on the element. Then we click on the machine or the buffer and we set it for the input and output. Okay, I will demonstrate all the connection that has been connected before, and we can see the flow of the every part of A and part B, and lastly it will go into the sink.
Okay, after all the connection have been shown in this project designs, now we continue to simulate these projects. So to simulate it, we have to click the run, and then we click the simulate, and there will be run. So you have seen here, I will click the run, and now we are setting the run times and warm up time. So based on the questions, it's given the total run time will be 128 hours. For the warm up time will be 8 hours. So we set here for the run time will be 128 hours, and warm up time will be set here as 8 hours, and then we click OK. So now it's running, so we'll have to wait for its results. So now we have completed on simulating the projects. To do the analysis of this output of this project, we have to click the run, and then we click the single run output, and then we click the model. So after that we will see the result analysis of this project. Okay, this is the animated runtime for this is the animated simulations for the projects. So as you can see here, the line 1 will flow the part A, and for the line 2 will show the flow of the part B only. So that is the simulations with animations. Okay then. Okay, after we finish the simulation of the projects, now we are focusing on the summary report of the projects. So now as you can see here, this is the summary report. We're only focusing on the output produced by the projects, which is in here by the sink. There are 4 sinks: sink A1, sink A2, sink B1 and sink B2. So the difference between the sinks A1 and sink A2 is focusing only for part A, but the difference is the part A have one-sided layout and the two-sided layout, same as the part B. So as you can see here, the finished part in sink A1 is 3,415, and for sink A2 will be 5,329, sink B1 409, and the last one with sink B2 is only 1,092. So now we are going to the machine. So we are focusing on the machine by its utilization. This is to determine which of the machine give a bottleneck in the projects. So now as you can see here, the least percentage in utilization is in flip 2.1 and sprint 2B. It just gives 6.061% in flip 2.1, and sprint 2B just gives 6.067%. So this is the least utilizations. So it is not the bottleneck in the project. But the bottleneck in the project is in C plus 17.1, so component place. So it gave the utilizations of 73.088%. So this is the highest percentage in utilizations between comparing by all the components. and it has relation to with the busy processing. So it's obvious the bottleneck is the highest percentage by 83.264%. So this one's obvious the bottleneck on the project. So now we are focusing on the labor. So as you can see here, when I'm comparing between these two labor A and labor B, as you can see the utilization here, the labor B is only for 14.154%, but for the labor A is 48.767. So that means that labor A is the higher utilization percentage than labor B. So this one need to be improving too. So these three factor is important to improving the output of the project.
The improvement that we have made from the output is by adjusting the utilization of the labor. As we can see, the utilization of labor A are higher than utilization of labor B. Means that labor A are doing more work than labor B. So we have to adjust the properties so that the utilization of labor A and labor B are same and we can increase the output. Firstly, we have to go to the model and we click on AUX. Then we have to click on the failure and then we click on the checking L1, which is for part A. Then we click on the repair process and we choose checking L1R. Then on the labor button, we have to adjust the labor A. We have to adjust the labor by putting number 1 in any labor. It means that if there are any machine that are broken and need to be repaired, any labor, either labor A or labor B, will go repair. Same goes to machine assist. We have to click on machine assist to labor 1 and then we go to the repair process and we click labor. Then we change the number 1 to any labor so that both labor will go to fix the machine. As we can see, after we have changed the labor to any labor, we can see that the output in the sink increases. We can see the finished part in sink A1, A2, B1 and sink A1, A2, B1 and B2 increases. Means that the improvement of the step of improvement for the labor can change the output of the machine. Next, we go to the second problem, which is the utilization of C place 17 are the highest among the machine. After we have changed the properties of labor 1 and labor 2, then we will run the project and we will see what is the output of the project. And as we can see, the output of the part A and part B increases. The finished part for sink A, sink A1, sink A2 and sink B1 increases. Means that the changes of labor 1 and labor 2 produce a good output to the project. Next, we will go to the S-Print 1. Next, for S-Print 1, we have decided to try to edit S-Print 1 because we can see in the table the utilization of S-Print 1 is 48%, but for S-Print 1B, the utilization is only 28%. It means that the S-Print 1 is doing a higher work than S-Print 1B. So we decided to edit one more S-Print 1 machine so that we can reduce the utilization and the busy processing of S-Print 1. And after we have added S-Print 1, we can see that the output of the part A and part B also increases. It means that the technique of adding a sprint 1 in the project can help to increase the output of the project. As Shahazureen has stated before, we can see that from the result, the utilization of C+17 are the highest among all the machine. It shows that we have to solve the problem by adding one more C+17 machine so that the utilization of C+17 can be reduced. And after adding the C+17 machine, we can see that the output of part A and part B also increases. It shows that by adding C+17, it can help us to improve the output of part A and part B. The next step is by trying to increase the time between failure of solder printing with 10%, and we have tried to increase time between failure in the breakdown, and it shows that after we change the time between failure by adding 10%, we can see that the output of the product also increases. It shows that the technique of increasing the time between failure can help us to increase the output of this plant.
Okay, after we are improving with the failure, now we are trying to do the cycle time decrease in the flip machines. At first, we try to apply it on the flip 1 machines by decreasing it by 10%. So when we doing this by decreasing the cycle time in the flip 1 machines, the output of the projects is decreasing. So it is not suitable to do this improvement. So then we change it to another flip machines, which is flip 2. So we apply these improvements. It shows and it's proof to us that it increased for all the outputs in the projects. So that means this type of improvement can be applied in the flip 2 machines. Now we are continue on the costing for improvements. So before I start presenting about the cost, I want to tell you that the labor does not give any cost for the improvements. So the cost here that we have done in this project is by doing the identical new sprint machines. So the cost is 20,000, and then we increase the time between failure to 10%. So it costs at 5,000, and then there will be the C+. So we add another C+ machines. Its cost will be 30,000, and the last one will be doing the cycle time decrease for the flip machines. So it will cost 6,500. So for the total cost for this improvement is 61,500 ringgits. So that means that the overall output that has been improved by this installment and this settings, it managed to increase by almost not almost but about 10% increase. So for overall performance. So that means that it has achieved the objectives. So anything you want to tell me?
I think that's all from us, and thank you for listening.
And listen. Thank you.